I've got a short amount of time, about 5 minutes here to describe a little bit about what we do and how we fit into the AI and energy ecosystem before we have a little chat on stage. So I'm Tim, co-founder, co-CEO of Sustainable Metal Cloud. I was trying to think of a way to describe what we do in a very short amount of time, and I guess I'd characterize it as we seek to solve AI's energy problem. AI has a substantial energy challenge and problem, which we'll unpack over the course of the next few slides. We started life in Australia, as you can tell from my accent, I'm Australian, about 7 years ago. Our mission and our vision, myself and my co-founders, was as outsiders to the data center and AI, or as it was known then, HPC industry, how could we apply engineering to turn energy into knowledge more efficiently? Now, what I mean by that is, for most folks, the data center is a place that data is stored. It's now becoming a place that data is processed. These AI factories are actually large engineering challenges. And our process was, could we start afresh? Could we think of what is the best way to do this and to accomplish this? So we started in Australia, where we built a 20 megawatt engineering center. The problem that we're trying to solve for, how to turn energy into knowledge as cost effectively and as efficiently as possible, starts with heat and cooling. And that is one of the drivers of AI's energy challenge. Roll it back one step, and the graph I've got on screen here, you can see a very clear trend. And what this is showing is that over the last decade or two, we've had real substantial improvements in chip density and chip efficiency. But as we've come to now 2 nanometer, 3 nanometer process nodes, we're getting less and less efficient with every step. And this has coincided with the rise of AI, which unfortunately uses the most energy intensive and hottest chips out there. So behind me on the graph here, you can see in green, we have the power limits of NVIDIA's GPU series. So this is ramping up at a very quick rate. And this is driving a massive challenge in the data center. So more heat in the data center means you need more cooling to remove that heat. And that is why our solution is quite different. So we use liquid. We've developed a liquid platform that you actually take the servers, you put them in, it's called single phase immersion, a full server in oil, and use the properties of oil, which has a heat coefficient 1,000 times greater than that of air, to remove the heat from the servers. Our system was designed to be modular, to go into any data center, and to host commonly found workloads in the AI ecosystem, like generative AI training using H100, Omniverse using L40S, and other types of platforms. In a nutshell, what it is we wanted to solve for taking any DC, like this diagram here, and coming up with a platform that would fit into that data center, whether that was built for liquid or not. So whether it was designed 15 years ago or whether it was designed this year. Either way, we wanted something that was agnostic to the data center that it goes into. And then on top of that, we wanted to improve the efficiency of the servers themselves. So by integrating the data center with our new type of AI factory, with an NVIDIA GPU-based server, we could achieve breakthrough efficiency, which we'll get into in more detail in the next session. Long story short, by vertically integrating this solution, we cut around 45 to 50% of the energy to run NVIDIA GPU-based workloads today over standard air-based configurations. We've designed this to be containerized so that we can deploy it in an existing data center, or we can build greenfield data centers. What we're doing here in Singapore is we've deployed 7 of these systems. We're deploying into India, we've deployed into Australia, and we're deploying into Thailand, and we're now looking to other regions and around the world. And the final slide before I leave you is, how does this get used? So we're actually trying to take this to as many places as possible. And one of the ways we do that is installing the infrastructure in the data center, making it an AI factory, but then making it easy to use by allowing others to consume this service as a managed service, whether it's a cooling as a service solution or whether it's a GPU as a service solution, with partners like NVIDIA, and customers around the world are able to access this today.